Hello everyone, today I would like to introduce the IMS Factory app. I would like to show how to work with it, how to make the configurations, and I will show first which hardware components we are using here, what is necessary for it, and as you will quickly notice, it is not much that is needed for it. What we have here is a transport system with a control unit, which is the Siemens PLC, with which we will connect via the app. And it is now connected quite normally to a router, in this case a Fritzbox via an Ethernet cable. And the Fritzbox does nothing other than creating a Wi-Fi for our application. This means that our Siemens PLC is connected to the Fritzbox via Ethernet, and then we have a Wi-Fi. And with this Wi-Fi, we later need to connect with the tablet or also with a smartphone. And we can then access the signals of the PLC via the app over the Wi-Fi. And that is what we want to do today. And for that, I will then show how to configure the app and also how to set up the project in the TIA portal and what needs to be configured there. I will start with the IMS Factory app now. In order to achieve this, I proceed to open the Play Store application on my device and then, in a straightforward manner, initially search for, locate, and subsequently install the application known as the IMS Factory app. Then I will first search for the IMS Factory app, which I have already found and can install. Now the app is being installed, and directly after it is installed, when it is completely installed, I can then also open the app once to check if it really works. So, installed, I click on Open, and the IMS Factory app starts 2001. That's enough for the first step for now. I can now set the tablet aside, the app is installed, and now I will move on to the TIA portal and perform the configuration there. I have already prepared something, namely I have created a small project. In this project, I have already finished configuring the control system, which is on the conveyor belt, 2001. So this is exactly the control with this I/O Link Master module, just as we have it in the hardware. And what I need to set now, the most important things are, on the one hand, that I set the IP address, this SPS, and what I also need to set is the putget function so that I can access it externally. I have already set the IP address down here. In this case, it is 192.168.2150. It is important that we know this IP address, we need to remember it. And when I go into the settings of the control, there is this connection mechanism, and I have to activate the put/get function there. This is very important, otherwise I cannot access the signals of the control system. That's all I need to set up in terms of hardware, and then I can start programming right away. Before I start programming any functions, I first need to create a variable table, and I have already prepared that as well. I have just created this IMS Factory variable table here, and I have only set up a few signals here, such as, for example, here from our left limit sensor, which is this sensor here on the left side and is responsible for detecting limits on this side. It has a fixed address, namely I13. The second sensor, which is the right limit sensor, is located on the right side and has the address I14. To control the motor to the right, we go via the digital output Q, and to control the motor to the left, we go via Q. Now here are a few more signals that we also want to use for the app. Because with the control, even if we want to access the signals from the outside, we are not allowed to control outputs, Q1.0 and Q1.1. directly from the outside. That means we have to take the detour via a marker. And for that, we have applied these 4 signals here. That means we can use this marker, M10.0, if we want to control the motor to the right. And we want to configure this marker in the app right away, so that we can then set this marker via the app. And when we set the marker via the app, the conveyor belt should move to the right, so the output Q1.0 should be set. We do the same for the left turn. For that, I have the marker M101 created, and in the app we can also display signal states. We can look at the signal states of inputs, i.e. the I13 and I14 of the sensors. We can display them directly via these addresses. If we now want to look at the outputs, i.e. Q10 and Q11 for right travel and left travel, then we also have to take the detour via a marker here. And for that, I then created these markers M200 and M201. And that's basically it. I don't need to apply more signals here now so that I can control this conveyor belt via the app. In order to gain full control over the system, it is essential for me to incorporate an additional function at this point in the process. In this particular section of the code, I have already created this specific function right here, and in this particular FC1, I will not be doing anything more than a simple assignment operation. If I now proceed to set a marker for this specific purpose, I have also strategically placed the word app right in front, so that if I set this particular marker here to drive to the left, then my output for the motor, which is responsible for left driving, should be appropriately set. I do the same here for the right-hand steering drive as I did before. If I set the marker for right travel in the app or in the application, then my output Q10 should also be set appropriately for the right travel of the motor accordingly. What we want to add now is that we also want to display that the motor is currently indicating that it is now moving to the right, to the left, showing the direction. And for that, we simply and easily incorporate a second instruction here by bringing these markers here, and through these markers we can then move to the right or left. Display left-hand drive directly in the app. And when I control it via the app, I have such control buttons, and if I control it through them, it can of course happen that I press too long and the workpiece carrier falls down, and I naturally don't want that. So I will add one more additional sensor here and negate that with the end position sensors on the left respectively. And accordingly, right? That means as long as the left end position sensor does not respond, that is my B1, as long as the left end position sensor is not set, I can drive to the left. And I do the same for the motion to the right hand side, where I also add an and negate this input for sensor B2 for the right drive. I appropriately call this function in my B1. Here is this function and that's it. I don't need to do anything more in the TIA portal now, and will transfer the project completely to my controller. So I have now transferred the project to the SBs, and the control is now running as well, showing us no error messages, which means everything has already worked. And in the next step, we first need to connect the tablet to the Wi-Fi, which we generate here via the Fritz box. First, I go into the settings and check our Wi-Fi, which is now called i4.0, and we are also connected to this Wi-Fi. That means our tablet now has a direct connection to the Fritz box, and the Fritzbox is connected to the PLC via an Ethernet cable. We don't have to do more for now, and we can go directly into the app. To do this, I will first start the app again and go into the configuration. So, in this app, there are two main menu items. One is configuration and the other is maintenance. And here in English as well. And I would like to configure first. So what would I like to configure now? We can configure different segments. A segment is a single conveyor belt or a control. And lines, these are simply combinations of several segments. So in one line, there can be a single segment or also multiple segments if you have a larger production line. We want to configure a segment first. Here are already two pre-configured segments, but we don't want to use them now. Instead, we want to add a new segment. And now I will first assign a name, and I can name it absolutely the way I like. Then I'll just call it conveyor IMS and done, which is quite easy, isn't it? And now comes the important part. Here I need to enter the IP address. And we had just configured the IP address with 192.168.2.150. And over the network, the app then also finds the control. Here we specify whether this is an 1200 SPS or an 1500 SPS, as we have an 1200 SPS. In the next point, augmented reality, we will get to that later, because first we need to define the signals that we want to use here. And you can find that here under the item marker. I am now adding a new signal and first assigning a name here. To do this, we need to recall what signals we actually had. We have the left and right end position sensors, and we also have the motor's left-right movement, once for control and once for visualization. That means we will start with the end position sensor first. I just simply write down here, sensor left for our left limit sensor. And now the address is required here, and the address was our I13. So this is exactly the address as it was also created in the variable table. What type of marker should this be? There are different types of markers. If we now use an input signal here, an I13, then we can only leave it on display. That means it is simply for display purposes, and our first signal is applied and we can already see it here. Then I will now implement a second signal to our right limit sensor, so sensor right. And this sensor has the address I14. And also just for display, now comes our first special sensor, not a sensor, but a marker, which we have also configured in the factory app. And that will be a signal to control the motor. So we want to manage and control. That means in order to, we call this here, in this context, for example, simply move right. And at which address did we have that? We had that specifically at the address M100. And now we can also select here what type of signal it should be. We don't just want to display, we really want to control, so interactive. And if we have set it to interactive, then we can select here whether the signal should be set as long as we hold it down. We want to toggle from 0 to 1 and back again. Every time we press the button, it should only be set or reset. What we are doing here now is I leave it on hold for a brief moment, and thus the signal M100 is kept on continuously on 1 as long as I press the button. And I will take over this for this sensor here. I will now make this configuration with the other sensors in the same way. And in the end, I will incorporate that into augmented reality again. I'll prepare this here first. I have now applied all the signals, also with show right and show left. And now, in the first step, we want to take a direct look at the signals in maintenance. I have not configured anything in augmented reality yet, because I want to do that in the second step. To demonstrate this process in detail, I have to set up a completely new line, which is essentially like establishing a new factory, so to speak. And I simply call it, for example, the normal factory app, which serves as a standard model, so that we now know this is our route that we want to work on here. Now I have created a new route under Lines Factory app. It can be seen there now, and I still need to define which segments are included. Now in this case we only have a single segment. For this I simply press the right symbol just right over here to add a new segment to this specific route. And we had this particular conveyor IMS. I check it in, and the app knows now that exactly this segment conveyor IMS is stored in this particular factory app route. And that's it. And now I can go into maintenance. Now I go to the maintenance menu and can now select which route I want to control here and choose my route factory app, the one I just created. And we can see directly on the tablet that we have a signal here, namely from the left end position sensor, which is this sensor that responds directly here. If I push the workpiece carrier to the right, then we no longer have a signal here, and we can also see that directly in the app. And in the same way, I can now also perform the control. Using the buttons on the right and left, I can control the drive here. This is now what we have configured so far, and what can be used with the control up to this point, without using such an AR anchor. Now we go back into the configuration, and at this point I set up and configure my segment conveyor IMS. As you can see, I have my signals here. Now I have to be okay here. Now I want to move in the AR environment. What do I have to do here now? How can I display them here now? And for that, I first have to position them in the room. In order to position them in the room, I have to swing around here with the tablet once, and then you can see all these little yellow dots. These are distinctive points in the room that the app needs to orient itself in the space. Then IR looks for this AR anchor, and we need this anchor as a reference point for our conveyor belt. And now we can already see an area, and we can bring our signals into this area. How do we do that? We first add a sensor and can now position this sensor where we want it. And we could also change its height now, but it fits quite well at this point. That's where it should be. And now we can assign another label here, indicating what this sensor should be called at this particular point in time. And now we can simply and easily assign another name. We call it left, and now we have to specify which sensor should be displayed here. And indeed our sensor left and safe. And now we already have our left end position sensor here. And up there we can also see our label, the one we just wrote in, left. And we will now do the same for our right end position sensor. In this step, we position the device carefully in the designated spot. Once positioned, we call it right to select the correct signal. We then ensure the sensor is aligned to the right. Finally, we save the settings to confirm everything is correctly configured. And we have already positioned our two end position sensors here. What comes next is our motor for right and left travel. And we can now position it as desired. We can now position this display as desired, and so that the workpiece carrier does not drive through it, I simply position it a little higher and simply say here, this is my motor. If he drives left, the signal should be displayed to me, and if he drives right, that should be displayed. And that's it. Save. So I have now also made the configuration in AR so that we can not only look at the signals in list form, but of course we also want to see the signals in the AR environment. And for that, I will now switch to this AR environment. I am now here in maintenance. So in the maintenance, and before I configured the signals and also positioned them in AR 2001. Now I sway a little back and forth here to find these distinctive points and then scan the AR anchor. And now we can also see our signals here. On the one hand, the left end position sensor signal, which is now green, on the right is red. Sure, the workpiece carrier is not in the right position, but in the left position. And up here I have my two buttons, to the right respectively. To drive to the left, I can now also use it for control. That means for the right drive. And then I simply drive to the right end position sensor, which will then also be displayed in green. And in this way, I can also drive back step by step. And the workpiece carrier only moves as long as I keep this button pressed. Yes, that was the configuration in AR, and now we have gone through it completely. That means we have configured the AR app, configured the TIA portal, created the project, and we can now directly control the signals in the PLC via the IMS Factory app and also display them in the AR environment. What we want to do now is not just take a single conveyor belt and control it, but we want to add a second one. And I will prepare that briefly now. That means I will prepare the project in the TIA portal with the configuration, and I will also finish configuring it in the AR app, and then add this second conveyor belt to this section, and I will show it immediately afterwards. See you soon. So I have now made the configuration here. I now have two conveyor belts here with two controllers that are networked with each other and also connect to the Fritzbox, and thus are also in our Wi-Fi. I have already configured the factory app. I added an additional second segment and simply called this segment Conveyor IMS2, and in our track, which is called the factory app, I added this second segment so the app knows that we not only have this one segment in here, but also a second one, which is right next to it. And now I can perform the necessary and essential routine maintenance. That means I go into the Maintenance Factory app and can easily and efficiently examine all the signals from both segments that I want to see. And we can see that we now have the workpiece carrier here at the left sensor, specifically from our conveyor IMS second. And in the same way, I can also perform the control by using the second conveyor belt on the right or control on the left. How does it work now in the AR view? In the AR view, I now have to swivel around a bit here again to see these distinctive points, and then scan the anchor here once. And we see that we only have a single anchor. So we actually only have an anchor here on the first conveyor belt, and this anchor is sufficient for us to see the signals for both conveyor belts here. This is just a little bit off now. I need to scan the anchor again because the camera was a bit out of focus, and therefore it didn't recognize the distinctive points correctly. Again. And we can now also see the signal states of the second segment here, and I can now also normally the right or make a left drive that was for the first conveyor belt, or also the right left drive for the second conveyor belt, ill drive back to the sensor. What we can also do here, because we now have several segments where the signals can be seen, all these segments, what happens, however, if we now have an error message in the system, that means, for example, some sensor is broken. I have now simulated this here once via a digital input signal, which I can now set directly here. Then I should briefly reload the anchor here again, and we get the signals displayed on site where we have configured them. But if I am here in the system now and there is an error somewhere in the first conveyor belt, I will simulate that by simply setting the sensor here. Then we get this error message displayed directly on the screen here in front, no matter where we are in the room. And we can then fix this error. Once the error is fixed, remove the signal again, then this error message will also disappear. And so they actually have the nice opportunity to configure everything here, to communicate with the app via the markers, via the digital input signals of the control. And yes, this way they can then move around in the AR environment. Yes, I wish you a lot of fun trying it out, and we'll see each other next time. Goodbye.